Furnace improvements was started in 1996, with a mission to improve the performance of existing fired heaters and boilers in refineries and petrochemical plants. Our goal is to provide low-cost value-added solutions for increasing capacity, improving efficiency and reducing NOx emissions.
FIS has been helping end users with design and engineering services for over 13 years. We have successfully completed over 200 projects. Our team consists of more than 40 professionals with over 300 years of combined high-quality technical experience. Our Delhi office was opened with 5 people in 2003 and has been growing ever since. We currently have over 20 professionals in the Delhi office.
This is our USA team and we are always ready to accept the challenge of your project. We take pride in doing high-quality technical work. We strive to provide 24-hour services with offices in both India and USA. This also reduces the time required to complete a project. We believe the most economical way to do a project is to do it right the first time. We have a long list of highly satisfied customers.
FIS specializes in revamping of all types of refinery-fired heaters for increasing capacity, improving efficiency, and reducing NOx emissions. Revamping focuses on working with existing components. It is an efficient and cost-effective way to get more capacity and reliability from existing equipment. We also offer our services to design and supply economical and reliable new heaters. The heaters shown in the picture are at a refinery in Port Arthur. These heaters were supplied by Petrochem. Foster Wheeler was the project management contractor. The heaters could not go more than 60% in load. They called furnace improvements to find out the deficiency in the heaters. FIS recommended the solution to bring the capacity to 100%.
Our skilled group of engineers have experience working on all types of fired heaters including crude, vacuum, hydrotreater, reformer heaters, CO boilers, coker heaters and waste heat boilers. We have even worked on fired boilers.
Our scope of services consists of process design services, followed by detail engineering, project services, erection and startup assistance. We have in-house CFD modeling capabilities. Our working methodology typically starts with an engineering study with approximately 30% cost estimates for revamp. It is followed by a project design basis report with approximately 10% cost estimates. The final phase consists of detailed engineering and project services.
This slide shows a partial list of our clients we've had the pleasure to work with. We have worked with most of the refining companies in USA. A detailed reference list can be made available on request.
We shall give a brief overview of the scope of work of a few of the projects we have worked on. As you will see in the following slides, FIS has vast experience in revamping heaters. Each heater is unique. The solutions we have provided in each case is custom designed and specific to the needs of that particular heater.
FIS has executed several efficiency improvement and NOx reduction revamp jobs. A few of them are presented here. The basic objective in the platformer heater number 4 revamp, located in Citgo, Corpus Christi, was to improve the thermal efficiency and to reduce NOx emissions to less than 0.06 pound per MMBTU. The client did not want to generate steam or preheat combustion air to improve efficiency. The stack temperatures were over 1100 degrees Fahrenheit. Thermal efficiency of the heater was only 66%.
The conventional series flow design was to preheat the fluid in the convection section and then heat it in the radiant section. The pressure drop in all 4 cells increased. Since 100% of the flow has to go through the convection sections, this design required large convection sections, new grade-mounted stack and large process piping. Cost of the conventional revamp was estimated at $6 million.
FIS patented split flow technique divides the process fluid into 2 streams. The convection section heats approximately 25 to 30% of the total flow and the rest is heated by the radiant section to the same temperature. The exiting fluids from both the sections are then combined into one stream. This requires smaller process piping and narrow convection section. The existing stacks could be reused, which eliminated the need for additional duct work and grade-mounted stack. Our cost was $3 million.
This table shows the comparison of major parameters before and after revamp. The heater capacity went up from 18,000 to 24,000 barrels per day. Stack temperature was reduced from 1100 to 478 degrees Fahrenheit. The thermal efficiency improved from 67 to 86%. 44 low NOx burners were installed. The NOx emissions were reduced to 0.06 pound per MMBTU. The pressure drop is lower and the firing rate also went down. The installation costs were half compared to that of the conventional series flow design. The estimated fuel savings were approximately $6 million per year.
These pictures show the heater before and after revamp. The job was completed in October 2002 and has been running since without any problems. The client was extremely happy and gave us a revamp study of another platformer. This crude heater in ConocoPhillips Alliance Refinery is the biggest heater within the ConocoPhillips system, with a heat duty of 750 MMBTU per hour. The scope was to install a selective catalytic reduction unit, to reduce NOx emissions to less than 0.01 pound per MMBTU. The convection section was split to get the correct flue gas temperature window for the SCR. A novel scheme was implemented by FIS that would save $5 million to the client. FIS option didn't require installing new ID fans or duct work. The IDFD fans were upgraded. FIS performed the CFD analysis to ensure there is proper mixing of ammonia with the flue gases in the SCR unit and there is uniform distribution of flue gases over the catalyst bed. FIS reduced the flue gas temperature, leaving stack from 420 degrees Fahrenheit to 300 degrees Fahrenheit, thus improving the efficiency by 3.5%. The annual fuel savings are approximately $1.5 million.
As you can see, this picture shows the conventional scheme versus FIS scheme. The alternative is to route the cold and hot flue gas ducting into convection section instead of the stack. The convection section is split into two parts by installing a blanking plate. This eliminates the need to install new ID fans and stack and saves on ductwork. This heater was commissioned in February 2009 and is running successfully.
ConocoPhillips approached furnace improvements to convert a CO boiler to a standalone refinery fuel gas-fired boiler. COP wanted to reduce NOx emissions to 0.02 pound per MMBTU. FIS solution was to install ultra-low NOx burners, flue gas recirculation system and dilution steam injection system. A new economizer section was installed which increased the efficiency by 4%. The steam superheater coil was revamped. This boiler had a number of operating problems which were taken care of during the revamp. Our client saved $600,000 per year in fuel gas consumption. FIS modeled the existing and new burners to predict the combustion improvements using CFD. This job was successfully completed in March 2008.
Furnace improvements was employed by Valero to develop the best capacity improvement scheme for number 2 platformer heater and NHT heaters. The 3 vertical cylindrical heaters along with the 3 cell platformer heaters share a common convection section and a stack. The heater was revamped not only for increased capacity but also for improved thermal efficiency and improved reliability. The capacity was to be increased from 12,000 bpd to 18,000 bpd. The process heat duty was increased from 120 MMBTU per hour to 151.51 MMBTU per hour. The conventional revamp option to extend the existing radiant cells would have space limitation, higher firing rates and very high cost. FIS split flow technology increased the capacity and had a design heat duty of 150.4 MMBTU per hour. The revamp cost was 1/4 of the alternate design. The thermal efficiency of the heaters was increased from 80% to 89%. The platformer heater burners were replaced with new ultra-low NOx flat flame burners. FIS scope included from process design to commissioning of this heater. Revamp scope included replacements of coils, radiant floor, burners, new convection section and stack damper. The heater was commissioned in November 2005 and has been running successfully ever since.
In the past few years we have started supplying new heaters on a turnkey basis. We have successfully finished commissioning for 2 heaters and are currently working on 2 large heaters. We plan to take up more new heater jobs in the future.
The first new heater job by Furnace Improvements was for Citgo Corpus Christi. The new vertical cylindrical heater is a combined feed heater with a natural draft. It is used to heat a mixture of hydrocarbon and hydrogen. The heater is designed for a heat duty of 49 mmBtu per hour and has an efficiency of 82%. FIS scope of services included design, engineering, fabrication and supply of this heater. The heater was successfully commissioned in 2005.
FIS was employed by Devon Energy to supply a new hot oil heater at Beaver Creek Gas Plant. This hot oil heater is designed for a heat duty of 25.0 mmBtu per hour. FIS executed the heater process, mechanical design, structural analysis, material procurement, fabrication and installation of the hot oil heater within an 8-month schedule. FIS also supplied the burner management system and procured all the instrumentation controls of the heater. The heater was designed for a thermal efficiency of 85% and was successfully commissioned in August 2007.
We have recently finished working on 2 new heater projects for ConocoPhillips. The BOO heater is a natural draft, vertical cylindrical heater. The heater is used to heat hot oil. The heater is designed for a total heat duty of 165 mmBtu per hour. FIS executed the heater process, mechanical design, structural analysis, material procurement and fabrication of this hot oil heater. In our previous job at Devon Energy, we delivered a 25 mmBtu heater within 8 months. COP requested an expedited delivery for this heater to meet their turnaround schedule. We took this challenge and delivered the heater to the site within 9 months of receipt of the order. The fabrication was done to such an extent that there were no structural welds at the site. All the connections were designed to be bolted connections. This is a 6-pass heater and radiant panels were designed for each pass to fit in each radiant panel. The commissioning is due this end month.
This is a second new heater job that we have executed for ConocoPhillips Wood River Refinery. COP was facing coking problems in their vacuum heater and they also wanted to revamp the heater to handle Canadian crude and reduce NOx emissions. FIS did the process study and as a result of the study, ConocoPhillips decided to build a new vacuum heater with an existing heater foundation. The new heater is 4 feet wider and FIS designed a superficial frame to make the heater sit on the existing foundation. This vacuum heater is a horizontal tube box with a convection section. It is designed for a heat duty of 42.82 mmBtu per hour. FIS scope involves design, engineering and supply of this heater to the site. This heater was erected in March 2009. FIS developed HPI software that can be used for all fired heaters to monitor the performance 24 hours per day. The software works by taking live data from the DCS and performs calculations to determine the performance of the heater. It will generate various messages to guide the operator if the heater is not working at optimum conditions. This software monitors all heaters' parameters like temperatures, draft, carbon dioxide, efficiency, coking in tubes, burner plugging, TMTs, to name a few. In our Energy Saver damper system, a control is installed on the stack damper to maintain constant draft. This system is very reliable to monitor draft.
This is a preview from our Heater Performance Index software.
Thank you very much for your time and interest. We look forward to working with you on your revamp and new heater projects. Please contact us with any question, training requirements or clarification you might need.